Hello, everyone, and welcome to today's webinar. We will start in just a few moments from now. Thank you for your patience. Hello, everyone, and welcome to today's webinar. Today's webinar will be a series of several webinars about enhancements in our GPP. And giving this webinar will be Michal Vinetsky, our product manager for SolidCAM. And as usual, this webinar is being recorded and will be available later on in the reseller area of on our website. And if you have questions, as usual, so write them down. And towards the end of the webinar, we will go through the questions if we have enough time. Okay, so Michael, I will make you now the presenter. And you can unmute yourself and show your screen and start.
Thank you, Sydney. Hello, everybody. Today we're starting with a session of webinars. So we will start from new major GPP features. We will not talk about everything what we have. In general, we will concentrate it in milling features. Okay, we are not talking about mill turn or this type or other types. Only about simple milling, and we will analyze how SolidCAM is support 3-axis, 5-axis machines with different kinematics. So it's our major customers. So let's start. First, everybody knows in SolidCAM 2018, even 17, we started to support multiple styles of rotation of coordinate system in SolidCAM. So I will start from a little bit explanation. So I think most of you know, but I will talk about it again a little. It's not only about 2021, also in previous version is the same. So in new versions of SolidCAM, you can define your routine of rotation of plane, of tilt plane, according to your machine. So as if you control your support earlier angles or work by spatial angles, today you can define any order of axis, any type of rotations. So firstly, our SolidCAM always supported kinematic axis rotation. So as a plane will be defined by machine kinematic. So if machine have 2 axes of rotation, like in a regular 5-axis machine, or so you will get only possible solutions for 2 axes what you have. But except of it, you can define any type of plane, tilt plane by order of axis. So let's start from 3 axes of rotation. So I will open any part. Okay. Okay, so we're starting from simple 3-axis machine. So it has the 2 machine, only 3 linear axis, no rotary axis, and I'm going to define my plane definition after I explain why I need it. So by default, we have this type of kinematic axis. So this machine don't have kinematic axis. So it means the plane cannot be rotated. So yeah, on this machine, the plane cannot be rotated. But if I define the custom order, so I will get plane for my operation in order the Y tag and X tags. So it means if I go now and save the operation, I can see what will happen on the machine. So if I make an operation on the side, so I can open my machine preview and see what I want to do. I'm going to drill on a side of the part. Okay. If I want to see how my coordinate system looks like, this will look like this. So it was rotated from this coordinate system to this by predefined order. Okay. But if my machine cannot support rotation, so this is kinematic axis, for the same operation, this is the same operation, this one, yeah. I will get coordinate system what's not rotated. So it is a simple explanation why we need to define a plane, a tilt plane for 3-axis machine. If your machine supports a rotation of plane, so you can use it even on 3-axis machine. But most of 3-axis machine are not support of plane rotation. Okay, except of rotation by 3-axis, you can also define it by 2-axis. I will not recommend to use it if you don't know exactly what you're going to do. It's for very limited of quantity of machines and very special controllers. So in 99% of machines, you will not need it. A plane can be rotated by single axis. By single axis, you can meet it in head table machines like Integrex, any Williamine, any B-axis machine, generally rotate a plane in most of the cases only around Y-axis, so you will define controller with Y-axis only. And the cycle 90 for now not supports the advanced features what I'm going to speak about it now. Okay, so if you want to use angular head features as stuff like this, so better do not use cycle 90. You can define same order of axis in your by custom plane rotation definition. So I explained, you have to define your tilt plane by the machine, and now in SolidCAM 2021, you will see also the result of rotation in machine preview. So with different on different machines, you will see different pictures in machine preview. So you will see exact what will happen on machine and how you will get G-code after you rotate the plane. Additional feature what we supporting in 2021, it's a machine plane. Okay, you will say we support also its previous version, but not exact. I will explain. Okay, so first of all, today the machine plane calculated relative to submachine coordinate system. Okay. And it's take into account all tilt plane rules what you defined previously in VMAD, and why you need it, you can use it for 3 cycles, execution, and compensation. And of course, in some cases, operation will be executed with no plane. I will show it on my part. So we will back again to this part, okay? And we will start from operations on the right side, okay? So on this right side, let's open some profile. Yeah, it was profile with ARC. Okay. On this operation, I just want to interpolate this chamfer, okay, for this feature with ARC. And in general, my machine not support plane rotation, so my coordinate system for position 2 will not rotate it. So my arc will be executed in ZY plane. Okay. So of course, if I'm going to make a G-code for this operation, I expect to see G90. Okay. And yes, it's what I see. And also the arc will be executed in same plane. Okay. And of course, we will use K value here instead of IJ. Okay. So to do it in previous version, you need to make a workarounds. In the current version, if I go to my post processor and go to ARC, of course, no workarounds here. Okay, we just printing, depend of machine settings, coordinate says what you need, and of course, okay, I will remove also change bit here, just a little bit more easy for us to understand what's going on here. Okay, so for this machine, okay, I need to make a circle, okay, in G90 set plane. If I make a same operation but on opposite side, okay, so in general I should get same plane, but I have to take into account the arc direction. So in this case, it was a clockwise, counterclockwise. In this case, it will be, when I rotate it in clockwise, but for me, it will be counterclockwise. So if I go into G-code again, sorry, it will clockwise, and I will see my arc also take into account the plane. So arc direction will take into account the plane what I'm working in, and I'm still in G90 plane. So if you want to make a arc, you don't need to play with directions and the planes and everything. So again, when I open the G code, you will see you get I, J, and K values here. Okay. So if you want to skip the 0 values, you can use the change bit, and also new feature in 2021. You can use change bit to skip 0 values. I will show it after how to do it. Okay. So you can view your machine plane, what it calculated in a machine preview. And you can define the machine plane in GPP by variable machine plane. Everybody knows it, okay? But today, this variable can have also additional value. It's mean none. So it's not only the plane, it can be also not plane operation. What I mean, it's if I want to make operation on this feature, profile or pocket, let's take a pocket here. Let's take this one, okay. It's not G90, not the 80 plane. It's something inclined. So in general, I cannot make arcs here because my machine not support plane. And I don't need to define plane for machine. So if I go to make a G code, I don't need a plane, and of course I will not get an arcs. So this operation will automatically split arcs to lines because it's not in the plane. In post-processor, you don't need to define nothing. And of course here, you don't need to split it manually. Okay. If in second case, if I define a plane in the machine like a custom, okay, and I will make a G code for it. So I will make it with trace 5. So in this case, we said our machines support plane rotation. So I will work in XY plane. So I expect to get the machine plane. So the machine plane XY is G17, okay? And of course, I will print my G17 values and you will find the arcs here, okay? So we automatically recognize if arcs can be built, so we will provide it, but if it's not, we will not trace it. So you don't need to care about it in post-processor or operation settings. So this automation can save a lot in the post-processor and help you to define angular heads machines what working without any plane in the machine. Okay, I will back again to real kinematic axis plane and we'll continue. Okay. So what's the limitation of machine plane? Pretty easy. Okay, in general, some machines not support drill cycles in non-plane operations. So Haas machine, for example, can drill only in G70 plane, so you cannot use it for in non-plane operation. But it should be managed in GPP. Okay. So yeah, we cannot cancel it automatically. So you have to switch in the GPP. do not use cycle for this particular operation. Sorry, in interface, but the checking for it can be only in GPP level, so we have to care about it in GPP. In general, drill is simple, so if I go to drill, okay, I can see just if my direction is not normal, just cycle is not important, if not Z, so cycle is not possible here, and make an error. Okay. Okay. We will back again to arcs plane, and SolidCAM today manage automatically in which plane we can execute the arc. So if we are not, if our operation not fit any machine plane, we will automatically skip arcs and divide it by lines according to the VMID settings. Okay. And arc can execute it in any normal plane. So it was a previously disabled function. So if I go back to VMID, okay, so we remember this variable was suppressed in previous version because of lack of support. And now we return it back, and you can define the XYZ planes, and you will get arcs. Not in any operation. In general, today it's only HSM, HSR, and Turbo HSM can generate arcs in non-normal planes, in not XY plane. But again, it's save a lot of G code and make program shorter. Okay. And so the variable arc plane will return you the plane of working, so it can be x, y, y, z, and zx. You don't have non value here because if it's known, we will not get an arc. And also we add the change bits for center relative coordinates to skip 0 values. So you can define in your arc procedure, okay, just put activate the change bits, and it will make your G code shorter and more compact. On some machines with low memory, okay, it can be usable, okay. But again, if you trace everything, all the 3 coordinates, it will not alarm the machine, it will work. Again, we did a lot of improvements in our arcs calculation. So first of all, precision of the center was increased, okay, of calculation. So we don't have today the problems what we have in some previous versions with not precise arc of center of arc in G code, and it was generate alarms. Also, it's for radius and for arc approximation, I mean approximation by lines, all with calculation was improved and switched to more precise calculation. And also we changed the defaults of minimum arcs length and minimum arcs radius to twice then fit precision, sorry, movement precision. It's mean if your movement precision is 3 digits, it can be maximum 2 microns, okay, to avoid this kind of errors. So today is the very safety, so, and operations with small arcs will not alarm your machine anymore. Okay. Compensation. It's also affected by the working plane. So of course, if you're working in XY or any other plane in machine support, you can use compensation. But if you start to work in non-XY, in non-plane, your machine can alarm it for sure, and you will not get proper tool pass. So today we take into account the tilt plane when we calculate the compensation direction and side. And so it also managed automatically. Just one point you have to theoretically, if I select compensation in non-plane operation, SolidCAM will calculate it and provide you G code. We don't have now how to avoid it from customer, okay, tools. So it has to be maintained in trace. So the example is like I have this pocket for the side. If I will select compensation for it, Okay, nothing blocks it for me, and I make a G code. Okay, of course, this job. Make it rough pass. Okay, so it enables the compensation, and it will not work on machine, so we have to manage it in GPP. Okay, so I have to add the GPP testing and provide an error if somebody try to use compensation in this kind of operation. Okay. And also, it's a very often asked question, 3D compensation in indexal operation. We are not talking about HSS or other ModelWorks based operation. I mean, Pocket and Profile, it's still not supported. So don't try to implement it. It will not work. Okay. Plain data. What we did in plain data, we have few variables, what we added to the trace. Okay. The first one is a plain data ID. It's just a unique ID of the plain data to use it to found related plane data for rotator plane. And also I just want to pay attention again, just rotate angle and earlier angle variables cannot be used for this kind of operation. Okay, so if you are starting to work on angular head machine or any other advanced machine, don't use it. Okay, continue to use a custom angle, and you will get all trace with all data inside and everything. Okay. We have additional setting in tilt plane. Let's say 4-axis tilt plane with tilt plane. It's not a subject for current demonstration. It's more for Milltown. So when we will make a training for Milltown posting, we will show how it works. It can help a lot on Integrex and NTX 1000 machine. And also, how I said, we enabled again the arcs in the XYZ plane. And additional, we change the logic of first angle pair interval. Is not a huge change. It's very, let's say, small one, but I just think I have to talk about. In 2020, in earlier versions, with a solution in the interval, any solution that fits the interval was selected as first. So in some cases on complex machine, you can find 2 solutions and both of them are fit the first axis interval, and it was make problems for ModelWorks. And today, what we are doing, we just calculating the bisector of the angle of the interval, and the closest solution to this bisector is the first. So we always have only one answer to this question, and never have to random select it, and it's done to avoid mismatch with ModelWorks because they calculated by bisector. So now it's more stable. Okay. GPP function. So I think everybody started to use GPP functions last years, and it's very easy to use tool and very nice. So what you see here is a list of most of GPP functions what we have. I think almost all else in previous version. Only last 3 what you see here is added in 2021. So of course we will document it. I think it's already documented, but I will not talk about it. I just put it here just to remind you, because I know Daniel will demonstrate and train it as well in his GPP training. So if somebody want to know how it works, you can refer in documentation or better to see Daniel's training. It's much more interesting. And also I want to put here in this demo the coordinate sets definition. Okay, it's just 2 pages. Okay, because we have a lot of questions which coordinate set I have to use. So here we have a clear picture, well-defined explanation how you want to use and for what you need to use the coordinate set. and please refer it, okay? And also we will update our documentation with this last updated definition. Generally, it's not changed too much, but it's always good to have it for your reference, okay? And you can select which coordinate system set you want to use for your machine. Okay, again, we are talking about new variables, so we try and do not add too much variables to the trace, and or we are adding functions, or we're just trying to avoid it. Do not make it too big, but we added only a small number of vars. So tool origin position, it's three variables, x, y, and z, where you can get the position of tooltip relative to the station in machine coordinate system. So for each tool, you can found this data and use it to set your machine in is exactly the same what you see in a tool table. If you open and see the tool origin, let's see it in tool table. Okay. So this tool, for example, okay, you see the red point, you will get X, Y, Z, the position relative to station. You can find your tooltip, okay? So in most of the cases, you have to invert it to use for G10, but it's simple math application. Okay. We have a tool tag. Tool tag is a variable. It's like unique ID of internal of SolidCAM of tool. So till now it was used only for SolidCAM for internal calculations, but to use functions, sometimes we need it. So just remember, if you need to trace it and print it in G codes, you're doing something wrong. It's only to use it in functions, GPP functions. So if you go in here, for example, and you're looking for some tool-related data, okay, on the okay, somehow you can see here tool-related data. So, but for some functions you will need, and also in the documentation, you will it's wrote you will need a tool tag. So this is a tool tag, okay, only for internal use. A station angle in turret, it was previously only for milling operations. Now you can get it for both milling and turning. Okay, and today we have a tool position. You can read it also in offset change and compensation routines. So it's also helped to define your tool offset change properly. And of course, submachine name sometimes is help a lot to make your post processor more readable. Okay. Okay. So before I finish this demonstration, I just want to go deep in the GPP and show what we did in on this example, what of this part. Okay. So this example, if I'm going to trace it, let's make ISO meaning. Yeah. So this is the G code for this part. We have two sides and arcs in proper direction and everything. Here we see everything is split by lines automatically and everything. So the G code looks good. Okay. In this simulation it looks, I don't see something dangerous. Okay. And let's see how the post processor looks. And I will start from general routine. So start of job, I'm using machine plane to define plane. The machine plane routine uses this machine plane variable, okay, as previous, okay. I just added additional routine what checked if it's not in plane, just to check if I not fit the plane. In general, it's very simple, nothing special here, and looks like any previous version. In start tool, it's very important to care about this spin direction equal to. it's to support deep drill operation. Okay, so to stop the spindle between movements, okay, if it needed. Okay, in rapid move for this particular operation, I'm using just a pose set and T-pose set to work with offset in the middle of the tool on the tooltip to different styles, and line, arc, the change bits are used here. Okay, in compensation, I'm just using side variable to detect error. If it's not in the range, I'm just printing error. Plain data, nothing special, just printing G10 with my Mac. Tool data, just printing G10 with my tool data and save it for next use. So I continue to go, and yeah, it's all 4,000 rows, and this post processor support all cycles of turning, for drilling, working with angular heads, internal routines, and subroutines. So everything what you need for 3-axis machine is supported in one post processor with 400 rows. Very simple. Okay, it may be customized for particular customer, but again, it can be really easy to create it and really easy to debug it. So I will summarize it a little and forget something very important. When we're talking about this subject, speed of calculation, I just want to show something. I've used here a variable what's called picture X minimum value. So if we go into any trace 5, our first operation, yeah, the GCAD calculation, make 5. It's very fast, and if I go to the setup routine, I see my fixture minimum and maximum, my fixture envelope is 0. It's not true because I do have a fixture in my part and it's not 0. So before we open the bug, okay, I'm just opening it to use, okay, and make G-code for the same operation. And now if you measure the time, it will take maybe 10 seconds more. Why? Because now we are, sorry, let's make it 5. So it takes few seconds more. And if I now go into setup, I will see the values are calculated. It means this variable, it's calling for some complex 3D functions in SolidCAM to calculate the envelope of the fixture. And if you don't really need it in your post processor, it will not calculate. So if I just skip it, you will not calculate these values again, and it will save a lot of time in calculation for complex fixtures. So just if you know, if you don't need it, don't use it, and it will make work much faster for you. Okay, let's back to presentation. Okay, so how we said we complete our conversion to floating variables format. It don't say too much, just it increase our precision in calculations and reduce cumulative error in calculation. So now the G-code is calculated much more precise. By optimization, what we did last year in G-code calculation, in 2021 we have faster G-code calculation up to 20 times relative to previous version. So if you have big operations, iMachining, 5-axis operation, the calculation of operation, it's not changed. But the G-code generation is much more faster, almost like in, I think it's same as in post machine no. So if your customer don't want to move to post machine yes, because of calculation of G-code time, now you can move him to fast machine yes. Okay, and we have cases like this. Okay. How I say the fixture boundary calculation can be skipped, and the G-code as coordinate says, definitions become very clear and simple. Okay, we don't have I say ups about it. Okay, machine plane according to the tilt plane rules behavior. So I think it's very important feature to support angular heads machines. Here, without this feature, your post processor is growing for 1,000 rows, and now with everything done automatically. Also, arc it can be executed in any plane and automatically splitting two lines if it's not in a plane. So compensation can be in any plane if your machine supports it, of course, and arc direction is also calculated according to machine plane. And we have this powerful feature is to define the tilt plane for 4-axis operation, 4-axis face operations, and we will show it, of course, in next demo, okay, for Milltown especially. Okay, so if you have any questions, I will be glad to answer.
Okay, thank you very much, Michael. We have one question over here that says, will the look ahead function in GPP come in the future?
We do have plan to implement it, and we have a definition for look ahead function. Okay, but till now it's not implemented in 2021. Okay, but we do want to do it. Okay.
Okay. Okay, so that's basically in the future we will have it. Okay. Okay, that is it for now. I see there's no more questions at this moment. Again, this has been recorded and will be available later on our website in the reseller area of our reseller webinars, and together with the presentation. Okay, thank you very much, everyone, for joining us in the webinar, and we'll see you again in our next webinar, part 2 of GPP improvements. Bye-bye, everybody.
Thank you very much. Bye-bye.